Page 617, number 7. Use mathematical induction to prove the formula for every positive integer n. And we're given a formula 2 plus 4 plus 6 plus 8 plus dot 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 plus 2n equals n times n plus 1. So this means if we want to add the first 10 terms, let's say, we know the answer is going to be 10 times 10 plus 1. Okay? But we want to prove this formula using induction. Now there's two steps to using induction. The first step is to show that this formula works when n equals 1. So my first step here, we're going to say when n equals 1, does this formula work? So my first term is equal to 2. Does that equal what I get when I plug 1 in over here on the right? So 1 times 1 plus 1. I think you'll agree 2 equals 2. So yes, indeed, it does work. So I'm going to put a check mark there. My second step, here's the difficult part. We want to show that if we assume that this formula works when n equals k, that it will also work when n equals k plus 1. So basically we're saying that if this formula works for any value of n, it will also work for the next value. And likewise for the next, and the next, and the next, and the next, on for any value of n. So what we're going to do is we're going to assume that this is true. 2 plus 4 plus 6 plus 8 plus dot 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 plus 2k equals k times k plus 1. Notice all I'm doing is rewriting that equation, but substituting k in place of n. So now we're assuming that that is equal. We want to prove that this is equal. 2 plus 4 plus 6 plus 8 plus dot 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 plus 2k. And then we want to put one more term in here, plus. Well, we want to prove that it works when I plug k plus 1 in place of k, or thinking up here in place of n. So I'm going to put k plus 1 into this spot right here. So plus 2 times k plus 1 is equal to. Now likewise, I want to plug k plus 1 into these two spots. So I'm going to say k plus 1 times k plus 1 plus 1, or k plus 2. Okay, now this next step here, here's the tricky part. This is the key to induction. Notice, all of this here is equal to k times k plus 1. So all of this down here, we can substitute k times k plus 1. So let's do that. K times k plus 1. And then we'll bring everything else down. Plus 2 times k plus 1. We want to show that that's equal to k plus 1 times k plus 2. So now, I need to do some algebra to try to show that both sides of this equation are equal. Let's use our distributive property, and let's write this as k squared plus k. Let's use our distributive property again to write this as plus 2k plus 2 equals, let's use FOIL over here on the right to write this as k squared plus 3k plus 2. And once I combine my like terms, I can see, yes, both sides here are going to be equal. So k squared plus 3k plus 2 is equal to k squared plus 3k plus 2. Now I can put a check by that. Since both sides are equal, that means that if any term works, the next term will work also. So we have just proven this formula is true for any positive integer n.